everyone, welcome back to the STEM Tutor. Today we're going to be solving this question using definite integrals on how to find the area of the region enclosed by the following curves: y equals e to the x and y equals x squared minus 1 from -1 to +1. So let's draw a sketch first. Y equals e to the x, it looks something like this. The y-intercept of e to the x is at 0, 1, because when we plug in 0 for x, we get 1 for y. And then for x squared minus 1, this minus 1 means the parent function y equals x squared has a shift down by 1, so it's going to look something like this. From -1 to +1, it would be roughly looking like this. And this would be the area between the curves. So we can use definite integrals to solve this. And the reason we can do that, just a little information on integrals over here. If I take the integral of a function f of x from two x values a to b, so for example, that can be from 0 to 2 of x squared. This actually means that I would be getting the area under the curve. So if I were to draw a rough sketch, here's y equals x squared, here's 0, and here's 2. The area under this curve is this green shaded portion. Without integrals, it would take you a very long time, because let's say I can split this up into infinite rectangles, or maybe 4 little rectangles in this case. And each rectangle could have a width of 0.5. So we have 0.5 to 1 to 1.5 and to 2. We could split this up into 4 tiny rectangles, and you could add them up that way, although you would be missing out on the curved areas here. Maybe this area in brown. You wouldn't be able to capture that with rectangles because this is a curve and it's not just a bunch of rectangles, although you would get very close to the answer if you did that. And you could find the area of each rectangle. You could find the height and keep the width as maybe 0.5. But if we want an exact answer, we would just take the integral. Finding the integral is pretty easy. Setting it up is the trickier part. So let's set this up for the area between two curves here. We only want the area from -1 to +1. So we're going to have the integral from, the b value is the value that is higher. So for us, that's 1. The a value is the lower value, so that's -1. And then we're going to have our two functions, and there's going to be a dx at the end because we will integrate with respect to the letter x, or the variable x. So once you have this set up, what goes inside the integral? It's not just one function like x squared. It's going to be both functions, but you need to subtract them. Okay, once we've set this up, we can now simplify the integral. Just one point to keep in mind: if this parabola wasn't here, and we just computed the area under the curve of y equals e to the x, you would end up getting this purple portion here. But when you do have two curves and you subtract them, your measurement is not the x-axis as your baseline. Your measurement actually ends up being the lower curve to the higher curve. So just make sure that there is a difference between just using one function versus, calculating the vertical distance between two functions. Once we have this, we're just going to expand. I'm going to expand this negative, so this becomes -x squared plus 1. I'm going to now split up this integral because every single term can be split up separately. And the integral of e to the x is actually just e to the x. That's a known integral that's given on integral tables. Some of these functions are special cases where there's no formula for them. You have to memorize the integral. And we put this vertical line to now indicate I took the integral, so I don't put this symbol anymore, and I don't put the dx. But I put this line to indicate this is the answer, but I will evaluate it from -1 to 1 afterwards. Let's do the same thing here. Now, any kind of polynomial or something like an x squared, x cubed, that has a very specific rule on how to calculate the integral. So you will take the exponent on your variable, because we are differentiating with respect to x. So I take the 2 on the x and I add a 1 to it. So that becomes a 3. And you're going to divide by the same exponent on the top. So now what happens, the integral of x squared is actually x cubed over 3. And again, from -1 to 1. And now whenever you have a constant number, a 1 or a 3 or a 5, you just attach an x to it. So instead of 1, the integral would be 1x, and you don't have to write the 1, so it's just an x. Now this is our answer. I'm going to just combine it and keep the bounds from -1 to 1 on the outside. So we have e to the x minus x cubed over 3 plus x, all from -1 to 1. Now what these bounds mean is that everywhere there is an x, I'm going to first sub in 1. So let's do that first. It's e to the 1 minus 1 cubed over 3 plus 1. And now I'm going to subtract it from everywhere there's an x, I plug in -1. So e to the -1 minus -1 cubed over 3 plus -1. Evaluating this, e to the 1 is e, minus 1 cubed over 3 is just a third, plus 1 minus e to the -1 minus -1 cubed is just -1, and then there's another negative out here which ends up making it a positive, and then plus a -1 is -1. Now I'm going to expand this negative sign and take the brackets out. I'll do that all in the same step, so everything flips signs and becomes negative or positive, the opposite sign. And now we have e minus a third, that's minus 2/3, plus 1 is plus 2. And I will change this denominator because this is 2 over 1, which is the same as saying 6 over 3, so that I can add these together, and then minus e to the -1. Now we have e minus 2 plus 6. So that's 4 over 3 minus e to the -1. And I'm going to make a common denominator here. If I multiply the top and bottom of this by e, I'll get e squared over e. So this becomes e squared minus 1 over e plus 4/3. This would be an exact number, and it would be units squared because it's area. If you do want to get a decimal, you can do that right at this step. So plugging it into a calculator would give you 3.68, or units squared. And this would be the final answer for the area between these two curves. So it would be about 3.6 units squared. And that's how you solve questions using definite integrals. Thanks for watching.